Come on, let us now calculate the atomic packing factor for an FCC. An FCC is a face-centered cubic. So we're going to calculate the atomic packing factor of an FCC. So you normally say that an atomic packing factor is supposed to be the volume of the atom, I divide it by the volume of the cube, So that means you have to find those ones. You have to find the volume of the atom, which they are supposed to be. We're going to see how many atoms we're going to have in an FCC, and we're also going to have the volume of the cube. So to get the number of atoms, we normally say they have 8 atoms at the corner. 1, 2, 3. They are supposed to be 8 at the corner because it's a cube, and each is an eighth. So to get the total, get 1/8 times 8. So from there, we do the addition of those one at the face. Each face has an atom, which is supposed to be a half multiplied by 6. So if we do this one, we're going to get total is supposed to be 4 atoms. That means we can proceed now, because it's an FCC, can be able to get the volume of the atom now, of those 4 atoms that we have. So we normally make an assumption that volume is supposed to be 4/3. We take it to be a sphere. So therefore it's supposed to be 4 times 4/3 pi r cube. From there we can have now that this one is supposed to be 4 times 4 is supposed to be 16/3 pi r cube. So we can proceed now to get the volume of the cube. So we get the volume of the cube. So we know the relationship between the radius of the atom and the lattice parameter is given as 4r is equals to the root of 2a. We make a, which is supposed to be the lattice parameter, the subject of the formula, which is supposed to be a, is supposed to be 4r over root 2. So from there, to get the volume, we normally say it's supposed to be a cube. Therefore, a cube is supposed to be 4r over root 2. I cube the entire part. Now I have the two. I have the volume of the atom, and I also have the volume of the cube. Now I can proceed to get the atomic factor using this formula. So you can say that the APF is supposed to be this one, 16/3, which is pi r cube, all over the volume of the cube, which is here, which is supposed to be 4r over root 2 cube. This we can now have this one as is equals to 16/3 pi r cube times the reciprocal of this, which now becomes as root 2. I cube it over, once I cube this one, I'm going to have 64. For this I'm supposed to have r cube. So the r and the r cube, they are going to cancel. So I'm going to have, if I take this one, a calculator with me, we are going to have, this one is supposed to be, this is supposed to be pi r cube. So we have said that this one and this one will cancel. So the only thing I'm going to remain with is supposed to be the root of 2. I cube, I multiply it by 16, and then by pi, all over this one times this one is supposed to be 3 times 64. So if you do this one, you're going to get 0.7404. So this is just approximately in percentage as 74%, which now is the atomic packing factor for an FCC. In our next video, we'll focus for a BCC and an SC.